Number 1. You remember square roots? Like what's the square root of 9? 3. Yeah. And why is the square root of 9 3? How would you explain it to a young person that didn't understand?
Divided by itself, or you multiply by itself.
Yeah, what multiplied by itself is 9, huh? Right? 3 times 3 is 9. That's what square roots are asking. What times themselves is this thing? So what if they give you a big number like square root of 144? You know that. Some of you know that. Good. And if you don't, just hit the buttons on your calculator. You'll have a calculator on the test. No need to learn it. That was actually number 1. How about, so number 2 is actually, so that was the real number 1. The first one was just an example. So the real number 1. Number 2 is the square root of 0.0025. Is that right? 0025? Yeah. 0025. You guys have your calculators? What is it? 0.05, right? You can put an extra 0 in the front if you want. That's optional. It doesn't matter, right? It doesn't change anything. 0.05. Be good there, because 5 times 5 is 25, and the decimal moves. If you remember the decimal movement rules. So let's keep going. Okay, so what is the square root of x to the 12th power? Now we're going to go to x's. So enough with the numbers. What about when we've got letters, like the square root of x to the 12th? How do we simplify that?
X to the 6th.
And why is that?
Because 6 plus 6 is going to be 12.
Right?
Because when you do the square root, they add together and not multiply together.
The powers add
Powers.
when the bases are multiplied. Exactly. Yeah, in other words, here's how we can put it. A square root, if you think about it, let me just give you a fresh screen for a minute. So what was the square root of 9 again? 3. Think about what just happened there with me. Y'all know the square root of 9 is 3. What was in that 9 all along? Well, 3 times 3, right? That's what was in there. So what we really just did, if you think about it, is we had 2 3s inside the square root, and we sent 1 3 out of the square root, didn't we? And that's what square roots always do. It's like a 2-for-1 deal at the store, at Target. There's a 2-for-1 deal at Target. Right? So what would be the square root of 25? You already know. It's 5. And what's the reason? It's because there's really 2 5s in there. 25 is 2 5s, 5 times 5. And that sends 1 out. So likewise, what is it, question 3? Yeah. When you have square root of x to the 12th, if you think about it, what is that? Well, it's 12 x's. 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to do it the long way first because I want to make sure you get the idea. So what is square roots doing? 2-for-1 deal. You tracking with me? That's the whole deal with square roots. They're a 2-for. We haven't talked about this before, have we? We're just now getting under roots, right? Yeah. So 2-for-1 deal. So what if you're shopping at Target? There's 12 items. They're on sale 2-for-1. How many are you going to pay for going out the door?
Well, I'm grabbing 2 and paying for 1.
Yeah, so to get all 12 items, how many will you pay for at the register?
6.
6 of them, right? Because these 2 send 1 X out, these 2 send 1 out, these 2 send 1 out, these 2 you pay for 1, these 2 you pay for 1, and these 2 you pay for 1. Altogether, X to the 6, as we've said. I just wanted to show it really clearly. It's a 2-for-1 deal, so it's going to cut powers in half. So you don't need to do all that work. You can just cut it in half. Right? But there's going to be more complex stuff, so you're going to want to know what's really happening. It's not always going to be so simple as just cut power in half. Good, though? Getting the idea. It's a 2-for-1 deal. You're at Target. You're buying 12 items. They're on sale 2-for-1. You go out of the store, out of the root, paying for 6. Right? All right. So let's go try. Number 4, they're saying square root of 3. They just want you to use your calculator. See how it says use calculator? So just hit the button. You guys have your calculator, so I want to make sure you know how to do that. Square root of 3, it's 1.7. And then I don't know anymore after that. 3.2? What comes next? 0.5. And they want me to round to the thousandths place. Which one's the thousandths place? Here's the number 1,000. Yeah, 3 zeros, third place after the decimal, huh? Thousandths place, thousand has 3 zeros. Third place after the decimal. Remember how rounding works? You circle that spot. You look 1 to the right. You're going to stop at the third place. Circle the place you're going to stop at. Look 1 to the right of it if the 1, and I don't care about anything else. I don't care about this 5 at all. I'm just looking 1 to the right of where I'm going to stop. I'm going to stop 3 places, 1,000, 3 zeros. I'm going to stop at the 2, or I'm going to move it up. You look 1 to the right if it's 5 or more, you go up. It's not, so 1.732. So there's the answer rounded to the thousandths place. How about square root of 360 on your calculator? Is it just 60?
16.
Oh, no, it's not. That'd be 3,600. I'm mistaken. I don't know what it is. Somebody got it?
That's a mistake on your YouTube.
Did I?
Yes.
Did I actually say the answer was 60 and move on? Well, I was not as sharp that day. Yes, it's funny. Yes. All right, so what's the answer? 9736. Thank you. It says round to the thousandths again. Can you round that to 3 places? 18.974, exactly. Right, we good there? Because the third place is here. Look 1 to the right. If it's 5 or more, you go up, right? So there we go. Now, why isn't it just 60? Why did I make that mistake on my other YouTube? Because 60 times 60 would be what? 36 with 2 zeros. 1, 2. That wouldn't be just 360.
2,600.
Correction to myself. Think a little more carefully. All right. So anyway, that's why it's not 60. All right. On we go. Now look at number 6. There's a 3 in the hook. So now we've got a different number. Now I say different. Was there another number in the other ones?
No.
There's 2, huh? How'd you know there was a 2, Natalia?
I guessed.
I just guessed. See? Let's go back and just think again about the square root of 9, and we say the answer's 3. Right? That's because there's 2 3s in there. It's a 2 for 1 deal. Sends 1 out. Now, why all this 2 stuff? Like Natalia was asked earlier. Is it always 2? Is it always 2? Well, it is because there's a 2 in the hook. When they're not showing anything in the hook, it really means there's a 2. And there's actually a good reason why we could already know that. What are we calling it?
Square.
Square root. Square. What's this called? X2'd? X squared. What's this called? So cube is math's word for 3, and square is math's word for 2, because square is 2-dimensional, cube is 3-dimensional, right? So when I'm calling this, we're all calling it a square root. Do you realize we're saying 2 root? That's exactly what we're saying. Where's the 2? It's invisibly there. Just like the atoms in the room right now. They're invisibly here, right? So the 2 is invisibly there. It's in the hook. That's why we were doing a 2 for 1 deal. If they put, now why don't they show it then? They just got lazy over time, like any field. You know, when you do the same thing a million times over and over again, this is the one they use most of the time. So after a while they said, look, if I don't write anything, I mean 2. It just sort of happened over time. That's the one most commonly used. So yeah, if they don't show anything in the hook, it means 2. If they want a different number, they'll show it. Okay. So well then, what are we trying to do? Let me ask you, what would be the cube root of 8? So if there's a 3 in there, it's a 3 for 1 deal, isn't it? It's a better deal even at Target. This is 2 times 4, 2 times 2. So it's the cube root of 2, 2, 2. I just broke down that 8 into what multiplies to be 8. Good so far. Still a little tree on the 8. 2 times 4, 4 is 2 times 2, 2, 2, 2. 2 times 2 is 4 times 2 is 8. That's the guts of an 8, right? Cube root says 3 for 1 deal. So this is a 3 here. So what's going to happen? 3 2's in, 1 2 out. All right, now we're ready. So what's our question? Cube root of 1/8. So that means you do the cube root of 1 on the top and you do the cube root of 8 on the bottom. We already know the bottom's 2. What's a cube root of 1?
1.
What times itself 3 times is 1? Yeah, just 1. Right? Because that's just 1 times 1 times 1. 3 1's in, 1 1 out. The root of anything with 1 is always 1, huh? The nth root of 1 is always 1. If that makes any sense. All right, we good? So far, so good? Making sense?
So you take the cube root of the numerator and denominator?
Yeah, you do both. Exactly. Yeah, so if you have a fraction, because that root was over both of them, wasn't he? Now, they'll give us, sometimes in a minute, we'll see some where it's just on the top, or that might be Wednesday, or just on the bottom. They will do that sometimes. This one you can tell is over both, so I do top and bottom. Exactly. Good observation. All right, let's keep going. To try that one, I would encourage you to just write out 6 X's inside there, and then do a 3-for-1 deal at target. Every 3 sends 1 out, right? So it's the cube root of 6 items, and the sign says they're on sale 3 for 1. So if you buy these 6 items, how many are you going to pay for going out of the store? You're going to pay for 2, aren't you? Because these 3 will cost you 1 item's worth, and these 3 will cost you 1 item's worth, so you're going to pay for 2. This making sense? All right, we good? 1. All right, 4th root of 4096. Let me rewrite it. Negative the 4th root of 4096. You know what I would do? I would probably guess. Does that sound funny to say for a math teacher to say? I would probably guess. I would start with something like 10. I'd say, I don't know. Now, remember, we're looking, well, fourth, well, am I confusing? I might be confusing you. Yeah, forget it. I mean, it probably would be the quickest way, but I'm probably confused. Just start breaking it down. So I don't know, and I don't have any idea what goes in, but I know 2 goes in, because it ends even, right? So just take 4096 and divide by 2. And that'll be 2048. See what I did there? And then 2048, how do you break that down? I don't know, but it's even again, so I know 2 goes in. 1024. Even 516. Even. Oh, thanks. I'm trying to do this in my head and I'm wrong. 512. That's 256. And then 2. Thank you. 128. 264. This thing just keeps going. Now, 64. 8 times 8. I'm going to break it down to something easier now. 8, 8, 2, 4, 2, 4, 2, 2, 2, 2. That's a lot of 2s. How many 2s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 12. 12 2s. I would double check. If it was my test and I really cared about my grade, I would double check. How would you double check? I would take 2 to the 12. You guys know how the power button, like the Y to the X or the up arrow, depending on your calculator. That's right, 2 to the 12. Make sure it's 4096.
4096.
Does that make sense? So make sure it's really 12 2s. Everybody see what I did there? I just kept breaking it down. Divide by 2, divide by 2, divide by 2. When I got to the 64, I was kind of out of room, so I put it up there and I did 8 times 8. Just kept breaking down, right? So all the leaves, the ends of the trees, all back to make sure it's right. 2 to the 12th, okay? So now let's finish up this problem. Negative 4th root. There's 12 2s here. 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 2s. And it's a 4-for-1 deal at Target. So 4 2s in, 1 2 out. 4 2s in, 1 2 out. 4 2s in, 1 2 out. So that's negative 8. We're done. 2 times 2 is 4 times 2 is 8. They're multiplying. They multiply on the outside just like they were multiplying on the inside, right?
So you just move that negative down?
Oh yeah, the negative's just sitting there. He never did anything the whole problem. He's been sitting there from the beginning. He's sitting there and he's a spectator at the event. He's just watching. That making sense? It's all good on that one?
How you write it on the calculator?
What's that?
How you,
Check that power thing?
yeah.
This? You should have an up arrow button, I think, or an X to the, maybe X to the blank, like that, I think, on your calculator. Manuel, do you have one of those buttons? So 2 to the power 12. I was just double checking that I didn't miss any 2s. I was just double checking that 2 to the 12th power really is 4096. That it really is made out of 12 2s. So that was just a check. That wasn't necessary, but it was nice to know.
But when you make the root, how you write the 4 outside the little house? You know that?
Is that?
Oh, the 4 in the hook there?
Uh-huh.
Oh, yeah. Your calculator, yeah, I'm not actually showing how to do that on the calculator. I mean, I could. It's kind of a pain. I don't think it'd be a quicker way to go. We have to do. I mean, if you really care about it, I'm not. I don't have time to do a lot of this, but I'll tell you. It's negative 49.6 to the 1/4 power. That's what you have to do. You got to use parentheses. You got to hit the equals, and it would take me 5 minutes to get you all. And rather than do that, they're going to be a bunch of X's in a minute anyway, and we're not going to be able to do it in a calculator. So I'd rather give you the idea because they're going to be X's in a second. But this would do it directly in your calculator. Why it's a fraction, we'll talk more about that on Wednesday. But anyway, is this making sense then? I broke that 4096 down to 12 2s, and it's a 4 for 1 deal, so every 4 2s sends 1 out. All right, we rewrite this in number 10. 6th root of 64x to the 30th. All right, can you try that same stuff? So take that 64 and just use your calculator and break it all the way down, and then you know there's 30 x's there, and it's a 6 for 1 deal at Target. All right, so 64, 8 times 8. 2 times 4, 2 times 4, 2, 2, 2, 2. So 6 2s. Did you get that okay? So always, like on a test, it'd be if you think you've got it, it'd be good just to double check. And you don't have to do anything fancy. You can just take your calculator and multiply 2 times 2 times, 6 times. It should be 64. It is. So I'm just giving you some ways to double check. Does that make sense so far? So we broke down the 64 into 6 2s. And now, how about all those x's? I'm going to write them out, but I'm going to write them out like, because I know this is a 6 for 1 deal, I'm going to write out 6 x's, and then 6 x's, and then 6 x's. And how many times am I going to have 6 x's? Yeah, 5 groups of 6, as you know, for 30. There's my 30 x's, right? So I just kind of broke everything down. The 64 is 6 2s multiplied, and then all those 30 x's. And so then you know the drill. It's a 6 for 1 deal. So 6 2s inside sends 1 2 outside. 6 x's sends out an x. These 6 x's sends out another x. These 6 x's another x. These 6 x's another x. These 6 x's another x. So 2x to the 5th, and we got it. Yeah.
Would you divide
Evelyn.
6 into
Yeah, so it's having done all that, wouldn't it have been a lot easier to just say, look, can't we just take 30 up there and then just divide by 6? Absolutely. That's right. If you were at Target and there were 30 items that you were going to buy and they were on sale and the sign said 6 for 1, that means divide 30 by 6, you're paying for 5, aren't you? Yeah, if you can see that and understand that, more power to you. Just crank it out. You can just jump right to here. What's that?
Do that every time?
Well, as long as it goes in evenly. Now, in times to come, maybe not today, but Wednesday, they would give me weird powers like x to the 32nd. So there's going to be some leftovers. So it doesn't always go in cleanly. That's why I'm showing you the long way, which will always work. But that shortcut is nice on this one. Yeah. Is that making sense on that? Questions I can answer? So break down that 81. And then you could just divide that power by 4, huh? Right? Because that's a 4 for 1 deal at Target. You're buying 12 X's. How many are you going to pay for? There's 12 items and they're on sale 4 for 1. How many are you going to pay for? So break down the 81, 9 times 9. The 9s are 3 times 3. So what do we have here? We got 4 3s, and then we got 12 X's. I'll write it all out, but you don't have to. So there's everything. So what does all that mean? 4 3s in, 1 3 out, 4 X's, 1 X, 4 X's, 1 X, 4 X's, 1 X. So what comes out? 3X cubed. Is that making sense? So you could have just divided that by 4, huh? All right, this getting easier? Making sense? What's in the hook there? There's nothing showing. So it means 2, right? It's a square root, a 2 root, isn't it? So there's a understood 2. I'll just write it in there. That's problem number 13 there. In the hook. Okay, so that means you're at Target. Let's just jump to the answer. Can we do that? I don't want to write 26 X's. So you're at Target. There's 26 items. They're on sale 2 for 1. How many are you going to pay for?
13.
13. Done. Good? Let's try another one. 14. Third root of -27. -27. X to the 6th, y to the 12th. Okay, so there we go. Let's try that one. If you want to break down the 27, go ahead. 3 times 9, 3 times 3, right? And then can you just flash to the answer? Oh, what about that negative on the 27? Do you know what that means? -3 times -3 times -3. 3 negatives makes a negative, doesn't it? Negative times negative times negative. So it's just the same old rule. How do you make -27? 3 negative 3s. So they're on sale 3 for 1 at Target. So you got 3 negative 3s inside. So negative 3's coming out, right? It's 3 for 1 deal. And then what do you do for the powers? Divide by 3, divide by 3, right? X squared, y to the 4th. And there we go. Is that making sense? So there were 3 negative 3's in there. It's a 3 for 1 deal. So out comes 1 negative 3, and then divide the powers. All right. Okay, so is that root over the whole fraction or just the top or just the bottom?
The
Whole fraction, both. So we're doing both the top and the bottom. What do you do on the top?
divide.
Just divide, right? On the bottom, can you break down that 16? If you don't already know it off the top of your head. That 16 is 4 times 4, 2, 2, 2, 2. So there's 4 2's on the bottom. Out comes a single 2 on the bottom. On the top, divide by 4, x to the 5th over 2. Good? So it's just okay. So f of x equals the square root of 2x plus 1. And they're asking for f of 2. Do you know that that's f of 2 and not f times 2? Remember that parentheses after a function mean plug into the toaster, put it in the x slot. They don't mean multiply. You aware of that? Remember that? So that 2 that they're giving me is going to go right there in the x. Yeah, because remember a function, this is like the holes in a toaster. Right? It's insert slot. It's not multiplication. It doesn't mean f times 2. It means f with 2 plugged into it. Plugged into the x slot. Huh? So they're just saying, hey, take that square root 2x plus 1 thing, and right where the x is, stick in a 2. With parentheses around it. That's what they're saying. You remember that with functions? They mean stick in a 2. You always put parentheses around something you plug into a function. And then just work it out. What is it? Square root of 5, right? 4 plus 1 is 5. I don't know. We can't really simplify that. Do they want a decimal? What do they want? Exact answer. Okay, that's it. Done. There's nothing more you can do with that.
2.24.
No, they don't want the decimal.
No?
Why don't you just leave it that way? Square root of 5. Just like that. They said exact answer. That means they don't want a rounded decimal. So why don't you leave it just like that? All right, so then with that in mind, let's try 20. Domain and graph. Okay. So on number 20, f of x is the square root of x. Is it minus 5? Or what was it? Yeah. Okay. All right. Domain. We've done a bit of domain, haven't we? It's been a while, though, right? Am I remembering that right? It's been a while. Domain, when you have the inside of a square root, you take out the inside and you say, hey, inside. Well, that I should say if you have a 2 root. Take the inside and say inside, you have to be greater than or equal to 0, and you solve it. Let me give you a reason why that's the case. Because you can never have negative in a square root. Remember? Let me reason with you again. What's the square root of 9 again? Let's just go back to the very basic ones, 3. And why? How would you explain to a young person who didn't know square root? 3 times 3 is 9. Okay, then what's the square root of negative 9? Is negative 3 times negative 3? No, it doesn't work. That'd be positive. And you say, well, yeah, just do 1 negative, 1 positive. Well, that's not the same thing times itself. That's its opposite. So you just can't do the square root of negative, can you? It's a no. It's not real. Later, we'll say it's imaginary and we'll do something. But for now, we just say it's not real. You can't do it. Now careful. That these are square roots, aren't they? What if somebody asked me for a cube root, say of negative 8? Could we do that? What times itself 3 times is negative 8? Yeah, negative 2 times negative 2 times negative 2 would be. So the answer to that is just a single negative 2. Huh. So notice we can put a negative in a third root, in any odd root, because 3 negatives is negative. That's fine. Right? You can have that. You can break that negative 8 down and say what times itself 3 times is negative 8? Negative 2 times itself 3 times is negative 8. But what times itself twice is negative 9? No way. So, therefore, you can never have a negative in a 2 root. So if they give you a 2 root and they say, what's the domain? You know what they're saying? They're saying allowable values for x. They're saying, what is x allowed to be? That's domain. Like if I said the domain of a microwave oven, I would be saying, you can't put metal in it, right? So the domain of a microwave oven would be anything but metal. You're not allowed to put metal in a microwave. That'll wreck it, right? The domain of these things is whatever x values are allowable. What's allowable? Well, the inside has to be not negative. How do you say not negative in math? Greater than or equal to 0. That's not negative. So what's inside? Having said all that, what do we do? What's inside the root? In our particular example, it's just x. So x has to be greater than or equal to 0. That's the domain. Let's go back to the question. Type your answer. Oh, interval notation. So they want me to say that in interval notation. Let me go back here again. Square root of x minus 5, is that what it is? Yeah. So the domain, you just grab the inside and you say inside greater than or equal to 0. And then how do you write that in interval notation? Do you remember? Like on a number line? That's 0 and greater. So that's 0 to infinity. Bracket at 0 because you include the 0, right? Greater than or equal to 0 all the way to infinity. It's all these numbers from 0 to infinity. That's interval notation. That's how they want the answer. And then the final thing is they want you to graph it, don't they? Choose the correct graph. Now, how are we gonna graph that thing? Yeah, you're gonna need to make a table, an XY table, and just plug in values. Now, what numbers? 0, 1, 2. Just plug them in to that function. right here. And the f of x, remember how that's y? Remember function values are y values? So this is going to be y equals square root of 0 minus 5, which is just 0 minus 5, which is negative 5. Plug in 1, you get square root of 1 minus 5, which is 1 minus 5, which is negative 4. And then go find the right graph, that's probably enough, you don't need to do any more, that has those dots on it. I know we're running overtime here. Let me just go look at the graph with you and we'll be done. So number 20. Do you see that, what I did? So A is out, B is out, and C is out. The answer is D because the only one that has the point over 0 down 5 is D.